our identity. Okay. So now, here we got 3 divided by 10, which is the same as 3 times 1 over 10. So from your identities, what is 1 over 10? 1 over 10 is cots. Okay, so now we got the power 4. So what do we need to do here? We now got it in standard form, cot to the power 4. So refer to 10 to the power 4. What we need to do is we need to get our squares. Okay, so remember the way we get our square for 10 and cot is different from the way we get our squares for sine and cos. Like, how did we deal with it yesterday? Remember k to the power 4 here for 10 and cot. If we have k to the power 4, it has to be k squared times k squared. But when we had sine and cos, it was k squared all squared. So now, so that will be k to the power 4 k squared times k squared. So that will be cot squared times cot squared. So what did we do after splitting up our exponents? So this was step number 1. Step number 1 was your exponent law. Step number 2 will be your square identity. So what is your square identity involving cot squared now? Square identity for cot squared, it's going to be 1 plus cot squared of bx, whatever b is equal to cosec squared. So you apply your identity to one factor only. Right, so you apply your identity to one factor only. There's 2 cot squares, but you apply it to just one of the 2 cot squares. Right, the square identity is 1 plus cot squared is equal to cosec squared. This is not 1 plus cot squared. It's just cot squared. So we manipulate that equation. What will cot squared be? Cot squared will be cosec squared of, in this case I got kx, plus 1 or minus 1? It will be minus 1. Alright, so now, that was step number 2. Number 3, what did we do, if you remember, for after we applied our square identity? You're going to multiply out. You multiply out. Alright, so be careful here. We're going to multiply 3 cot squared times cosec squared, and then 3 cot squared times minus 1. But don't forget to include your integration and dx there. So that will be 3 cot squared kx times cosec squared of kx dx, then 3 cot squared times minus 1, which is minus 3 cot squared of kx dx. So we multiply out. So now here, step number 4, what do we do? we need to apply our square identity again. Right, so you apply your square identity here by cot squared. There's your square identity, 1 plus cot squared is cosec squared. So cot squared will be cosec squared of kx minus 1. So now, after your square identity, what you can do is multiply out again. Right, so let me multiply out. So if I multiply out here, minus 3 times cosec squared is minus 3 cosec squared of kx dx. Then minus 3 times minus 1 will be plus. Okay, you can write it as 1 times 3. I'm just going to write down the 3 there and the 1 there. Okay, it's the same thing. Negative 3 times negative 1 is positive 3. So now let's just write it down in one line. So this is equal to 3 times you got cot squared of kx times cosec squared kx dx minus 3. We got, what do we have here? Just cosec squared kx dx. And the last term there is plus 3 times 1. Right, so what type is this? This is type A. How do you know it's type A? Because the derivative of cot, we differentiate cot, it will be negative cosec squared. So here we can use our substitution. So remember, this is type A. So that is f of x multiplied by the exact derivative. So you always let u equal to f of x. F of x in this case, is it cot or is it cosec squared? It's going to be cot. So that is cot of kx. So du dx, the derivative of cot. The derivative of cot will be negative cosec squared of kx times the derivative of kx, which is just k. So therefore, you make dx the subject of the formula, which is du divided by minus k cosec squared of kx. Now substitute. So you are replacing cot. Right, so here, only this part here is type A, nothing else. So this is your type A. So what did you do here? You are replacing cot. Is it you are replacing cot with u, and then you're going to replace dx here. So there's your cot. So that's cot squared, so it will be u squared. And here you are replacing dx with du divided by minus k cosec squared of kx. So now, what can we do? We need to simplify here first. So this is equal to You got 3 divided by minus k, which is going to be minus 3 over k. This is u squared. Okay, I'm just going to integrate one time only in one line. Alright, so here, that's my du. Now I can integrate. Here I'm integrating with respect to u, and here with respect to x. Integrate u squared, that will be u to the power 3 over 3. What about this one? Here, you need to go to your formula sheet, so you need to make a note of this here. It's not given to you on the formula sheet under integration. This is given to you under differentiation. So you are looking for the derivative of something that gave you cosec squared, and then you work backwards. Okay, so on your formula sheet, but anyway, there's it right here. Okay, the derivative of cot is negative cosec squared. So the reverse process, if you integrate cosec squared, you will end up with minus cot. But remember, there's a minus here, so you also put the minus there. Right, so now you got minus 3. You are integrating cosec squared, which is going to be minus cot of kx, all divided by k. Don't forget to divide it. Plus 3 times the derivative of 1 with respect to x is just x plus c. And you're done. All you have to do is substitute back there. Okay, here I can see these two cancel, 3 and 3. So I end up with minus 1 over k. What was u? U was, there's u here, u was cot. So that's going to be cot of kx to the power 3. Here, I got the negative times the negative, which is positive 3 over k. That's cot of kx plus 3x plus c. There's nothing more to simplify here. Right. Right, so here you have a fraction. There you also had a fraction. Okay, but here you have a negative exponent. So it's not your identity. It's not an identity, it's an exponent law. So all you have to do is, if I had something like this here, 4 over 3k to the power minus 4. This is the same as 4 over 3 times 1 over k to the power minus 4. So all you're going to do is, you are taking k to the top. So this is equal to 4 over 3. If I take k to the top, it becomes positive. It's an exponent law. Okay. So now, this is 4 over 3. You take cot to the top, it becomes cot to the power 4. That's all. And then, we follow the recipe. So, the exponent law, it was not an identity, just an exponent law. So now.
So,
yes.
it's still blurs.
Yeah. I don't know. Let's see what happened here.